Okay, so we understand how inheritance works on a basic level. We've gone into Java and we've extended a class. We've tested that to make sure it's working on a very basic level. For the next part, we need to understand how method calls work in an object-oriented programming environment. We're going to consider a situation in which we have two classes that we're going to start with. We're going to have a friend class and a family member class. And these classes will encapsulate all the things that we keep track of about these two different sets of people and all the behaviors that they have. We then are going to add a close friend class. Now, a close friend is probably a lot like any other friend, but maybe has some special behaviors that a regular friend doesn't have. And so we can consider an inheritance arrangement here. We would say a close friend extends friend. And this setup does pass our is a test, right? This is where we say, well, a close friend is a friend. That works. And so that suggests that this is probably a good arrangement for our inheritance. If we add another class to the mix, that is best friends, and it turns out that our best friends are our cousins, so now we have this class that causes a little bit of a problem. Is a best friend cousin a friend, or is a best friend cousin a family member? The logical solution here would be that it can extend both, right? Because a best friend cousin is a friend and a best friend cousin is a family member. But as the Beatles might say, you can't do that. At least you can't do that in Java. This would be called multiple inheritance. And it's where a subclass has more than one superclass that it extends. Some programming languages do allow this, and the problem with it is that you can run into situations where there's an ambiguity concern, right? We want to run a method in one of the superclasses, and we don't have any way to be sure which one gets priority here. So the developers of Java just avoided it and said, well, we're just not going to support that. We're not going to let you do it. Java does have something called interfaces, and interfaces give us kind of a workaround. They give us a way that we can have something like multiple inheritance, but that avoids that ambiguity problem. That's beyond the scope of what we're talking about here, but it is an option. So in Java, we can't do multiple inheritance in that sense, but what we can do is what we might call multi-level inheritance. And that is to say that one class can have a superclass and can have only one superclass, but that superclass can also have a superclass, and that superclass can have a superclass, and we can go as far up there as we need to go. This idea ends up resulting in what we can call an inheritance hierarchy, which is the kind of a visualization of how all of these inheritance relationships fit. And there probably would be other branches to this. Like, for example, we might have a work friend for someone who you don't really like, but there's nobody else at work, so you have to hang out with them there. Or like a frenemy that you are nice to each other's faces, but then talk bad behind each other's backs. Those would be whole other sections of this hierarchy. We're just going to figure on talking about this one kind of branch that happens to fit nicely on my screen right now. Now, these three classes all have methods, they all have behaviors that they offer, right? So a friend can give us a hug. A close friend can be honest with us. If we ask them, do these shoes make my feet look big? They'll give us a true answer. But since a close friend is also a friend, they inherit the ability to give us a hug. That means, of course, that a best friend inherits the ability to be honest about our shoes and to give us a hug. All the way up the inheritance tree, we get to inherit all that stuff. And then a best friend adds on the ability to lend money. Now, because these inheritance hierarchies can get complicated and big, it's important for us to understand how method calls work. So let's imagine that we have an instance of the best friend class, and we're going to call it BFF. and we want to call the honest opinion method for that BFF. We need to ask them about a pair of shoes we're thinking about buying. So here's what the compiler does. It's going to look and see that, okay, BFF is an instance of best friend. So it goes to the best friend class and it looks for this honest opinion method. Of course, it's going to look around here and not see that. But what it is going to see is that, oh, best friend doesn't have an honest opinion method, but it does extend close friend. So I better go look there. And so it's going to go up the inheritance hierarchy one level, and it's going to look in the close friend class. It's going to look and see, oh, here's an honest opinion method, so I'm going to use that. If we try and call a method that doesn't exist, like we try and ask we want to ask our BFF to go on a date, which is not a behavior that a best friend has. We probably shouldn't be doing that. But it's going to come to the best friend class. It's going to look around and say, hey, I'm looking for a method to go on a date. Nope, but this extends close friends. So let's go look there. Looks around. No go on a date method there, but that extends friend. So we better go to friend and look. No go on a date method here either. And so now we have a crash, right? Once it gets to the top of the inheritance hierarchy, if there's no method there, our code is not going to compile. Now, we're going to see in a little bit that there's a little bit more to this. There's kind of one more step in the process. But for now, that's our understanding of how this works. A method call is going to start out in the subclass, and it's going to work its way up through superclasses until it finds an implementation it's looking for. Now, what happens if we have a situation where a subclass inherits a behavior, but it does that behavior in a little bit of a different way? So, for example, a close friend inherits the ability to give a hug, but a close friend hugs in a different way than a friend does, right? This type of situation is called overriding, right? Not to be confused with overloading, which is a topic that you probably learned about previously. In method overriding, it means that a subclass is going to customize an implementation for a method. And because we understand the way that a method call works up the inheritance hierarchy, we know that a best friend, if we call the give hug method, it's going to move up until it sees an implementation for that. Essentially, it means that a best friend hugs the way that a close friend does, which is maybe a little different than the way a friend hugs. All right, so this is all great with these examples of friends and best friends and things like that, but let's go ahead and connect this a little more to some code that we're going to write. So here's an example that we have used in previous videos. It's a bank account superclass, and then we have implemented a checking account. We also implemented a savings account that's not shown here. And what we want to add right now is a VIP checking account so that we have that idea of multi-level inheritance, right? A VIP checking account is a certain type of checking account. And I don't know, you get a little bonus when you make a deposit if you're a VIP. What I want to point out here is that the VIP checking account has a deposit method just like a bank account does. So this is an example of overriding. It's a little different than our previous example because we're skipping one class in the middle. It doesn't matter. The idea of an override is that we're going to implement a method to replace something somewhere up the inheritance hierarchy, right? So a deposit for a VIP checking account works a little bit differently than a deposit for a bank account, which is inherited by a checking account. If we look at that checking account, I do want to point out we have a write check method that really is almost the same as a withdraw method, right? They both withdraw money from the account. Writing a check involves a little bit of other information. This is not actually an example of overriding. For it to be overriding, you have to use the exact same method name. All right, so the deposit methods, this VIP checking account deposit overrides the bank account deposit. The write check method happens to do something very similar to the bank account withdraw, but it's not really overriding. Let's go ahead and jump into Visual Studio Code and see some examples of this, and you can get the files that I'm using from Canvas. I've spent all this time talking about friends and close friends and best friends. We should at least see a little example of this in code. I don't even know if I'll post these files because they're just really simple classes. The first one is a friend class, and it has a give hug method. So if I come over here to my test program, which just makes one instance of each, so I can say friend.giveHug. And if I run that, it says this is a friendly hug. Now, if I have a close friend, so I'm going to delete that, and I have my close friend dot, what can a close friend do? Oh, the close friend can give an honest opinion, so I'll run that. So our inheritance seems to be working. Let's take a little bit of a look at the overriding. So my close friend class extends friend. It has an honest opinion method, and then it has a give hug method. So this is the override. When I have my best friend, my close friend or best friend, because it inherits from that, give a hug, it shouldn't say this is a friendly hug this time. It says this is a close friend's hug. And if I change that to BFF, BFF inherits give hug from from close friend. So we should get that same output. So far, so good. There's not much to this syntax here, but you got to be careful that you are naming and including case sensitivity your method the same as the superclass method you are overriding. And to help you with that, there's something we call a compiler directive. And so this is the at sign, and I'm going to say at override. And this has no impact on the execution of the program. This is just a message to the compiler that says, hey, this next method is supposed to be overriding something in a superclass. Again, it doesn't change, oops, that one's not going to run. Let me switch over to my test. It doesn't change the way anything runs. It still says this is a close friend's hug. What it does is it helps catch any mistake you might make when you're overriding, because it's really easy, for example, to have a typo. Without that override directive there, that doesn't give an error because this is not bad syntax. It's called give hug without the E in there. Well, Java doesn't know that's a misspelling. It's just another method. But when I run my code now, save that, come over here and run it, I should be getting a close friend's hug, but instead I'm giving a friendly hug. I called give hug. It came to best friend, didn't find any of those. It came to close friend. It didn't find the correct give hug. It found this other one, but it didn't use it. And it went up to friend and it ran that one. So the override directive is just a way to help catch the errors that you might make. I often forget to use it, but I encourage young programmers, beginning programmers, to use that because it is easy to mess those kinds of things up. So that's just a really basic example of multi-level inheritance and method overriding. Let's switch gears and look at that bank account example. Okay, so this is my bank account class. I think it's pretty much where I left it off after that last video. Nothing particularly interesting to us here at the moment. Then I've got my checking account, which extends a bank account and it adds the ability to write a check. And the one I'm creating is going to be called a VIP checking account. And so now when I go to extend this, I'm going to say extends checking account because this VIP account is a form of a checking account. And I've misspelled extends, there we go. And the idea here is I want to override the deposit method. And we're going to make it so that if you have a VIP checking account because you're rich and fancy and have one of those little monocle things in your eye, whenever you make a deposit, you're going to get like a 0.5% bonus or something like that. So I have that override compiler directive, and now I'm going to say public, and I've forgotten. I don't remember what my deposit method looks like. So I'm going to go check a deposit method. It's a void method. It takes an amount. And by the way, it wouldn't have to be exactly this. I can't remember what it was. And so I want to get it right the first time. But okay, so it's going to be public void deposit. And if I was messing it up, the compiler override would help me anyway. Double amount. All right. So first thing I'm going to do is I'm going to calculate a bonus here. Double bonus equals amount times, I'm never good at math, but if I want 0.5%, half a percent, I believe that's 0.0005. Am I doing that right? 0.05, I think I went 10 too far. We'll find out. And then we're going to say that this dot balance equals, or we'll just say plus equals bonus. Now, we've run into this error that we have seen previously. Balance is a private variable in BankAccount, so I don't have access to it. Remember that we had two solutions. I could change that private keyword to protected, and that would give me access to it, and that's not a bad solution. I certainly don't want to change it to public. I think I made that clear in the other video, but I can change it to protected, and that would give me access. And I said I also could just call a method in the superclass, excuse me. So if I say deposit, and I'm going to deposit the bonus plus the amount, let's see what happens if we run this. So I'm going to come to my test account. I'm going to not going to write the check. I'm going to try and make this as simple as possible. So I'm going to put in $100, right? Because a nice even number. And then we're going to print out that balance. Oh, and I almost made a mistake here. I need to change my checking account to a VIP checking account. And I probably should rename that so I don't confuse myself again. I like to use the little rename function in VS Code because then it's sort of like a global find and replace there. Let's go and run this and see what happens. I've got this odd error. Okay, I've got this message that has printed out a whole bunch of times, and I'm not sure what's going on here. Well, I am, but you're not sure. So let's take a look. We're going to use the debugging feature in VS Code for this. I'm going to set a breakpoint, and let's run this again and see what happens. Oh, and I've made a mistake. I ran it instead of saying debug it, so I got to change that to say debug Java. There we go. Now we've stopped, and here I am at the VIP checking account equals new VIP checking. I can step over that. I can step over that, but this is the one I'm interested in. I want something's going wrong when I'm doing my deposit. So I'm going to step into that method. And I've got some variables over here. Amount is equal to 100. That's good. I'm going to step over that. And my bonus is now 0.5. Okay, so 50 cents. I think that's right. Again, if my math is serving me correctly. And now I've got this call to deposit. Remember, I want to call the deposit method in my superclass so that it just does that deposit for me. So I'm going to step in here. Oh, and it didn't go to my superclass. It stayed right here in VIP checking. And it's just going to keep staying here. It's calling itself. So we call this recursion. And there is a way to use recursion intentionally where it essentially is a loop. But I haven't done that here. This is just an error. And what happens is every time you call a method, the Java runtime copies a bunch of stuff related to that method and puts it in a place on the memory called the stack. And eventually that stack runs out of room, and we say that the stack overflows, right? So I'm getting a stack overflow error. You probably know that phrase Stack Overflow as the site where you go to cheat when you're stuck on one of your homework problems. But that's where it gets its name. It's from this idea of a Stack Overflow error when that area of memory runs out. So we've got to solve this problem. Again, I could just change it to protected, but this is a good chance to teach a little concept here. I don't want to call this deposit method. I want to call the deposit method for my super class. So what I can do in Java is say super.deposit. And the super keyword, this is essentially like, I've always do things with like this. Okay, this dot deposit would refer to this object. Super refers to the super class. So now let's save that and try running it, see if that solves our problem. I'm going to turn off my breakpoint and be optimistic that this is going to work. Okay, $100.50. So it did work. The concept here is that when we have a need to call the superclass version of a method specifically, we can sort of prefix that with super dot, and it will jump to that superclass. And what it actually does is it just starts moving up the inheritance tree from here until it gets to another implementation of deposit. Because remember, the superclass here is checking account. Checking account doesn't have a deposit method. So then that extends bank account, it comes to bank account, and it finds it there. This is a concept that we're going to come back to in an upcoming video because it has a really important role, this idea of calling the superclass when we get to it. But for now, this is just a nice little example of how we can have multi-level inheritance and how method calls are going to move up that inheritance hierarchy and allow us to do things like method overriding, which is giving a custom implementation of a method within a superclass. Now, a few minutes ago, I talked about how a method call moves up the inheritance hierarchy, in this case, BFF go on date, which doesn't exist. And when it gets to the highest level superclass, it then essentially won't compile from there. But I had that little comment that that's actually not quite it. There is another step to the process. So there is one more thing that plays into this idea of method calls and this hierarchy, and it's probably easiest to just go into Visual Studio Code and show you. All right, there's a method that has kind of a special behavior in Java. It gets treated a little bit differently than most other methods. And so I'm going to demonstrate this by using a print line statement. And what I'm going to print out is just my instance of the VIP checking account object. So that's VIP1. Now, VIP1 is not a string, it's an object. If I run this, I'm going to turn off debugging here and just run it regular. What I get when I print out an object, it looks sort of nonsensical. It actually is, it does mean something. So you can read some of it. It's the name of the class that this object is an instance of. And then it's got this thing that we call a hash code. You can think of it as kind of an address in memory where this object can be found. So it helps the runtime find this object when it needs to use it. Well, what happened here is that the printline method really just takes a string, and a VIP1 is not a string, it's a VIP checking account. So what the compiler has done essentially is it has added on to that a little method called toString, as in we're going to convert that object to a string. And if I run this, it should work exactly the same way, because essentially I believe the compiler actually is just adding that call on when it compiles. I think I'm accurate when I say that. But certainly conceptually, that's what's happening. So where does that come from? It turns out that there is one class to rule them all in Java, and that is a class that is called object. And since I don't have a fancy PowerPoint up there for this, object, a class called object. And every class in Java extends object if it doesn't extend something else. So in other words, VIP checking extends checking account, and it can't extend anything else because there's no such thing as multiple inheritance in Java. But checking account then extends bank account. Bank account, finally, we get to one that doesn't extend anything. So again, I'm not sure if I'm 100% accurate, but I think we can think of it as the compiler is inserting a line here that says extends object. All right. And the object class provides a handful of functionality that every object in Java needs to have. There's not a lot to it. You can look it up online if you're curious. But the main one that we interact with is this toString method, right? Because often we want to print out an object. It is a method just like any other method, so I can override it just like any other method. So I'm going to come to my VIP checking account, and I'm going to use the override compiler directive again. So the toString, I happen to know this, you would have to look it up if you didn't, but public string toString. And I've misspelled it. That was not intentional, but it does reinforce the idea of this compiler directive, because if I didn't have it, it would think that, oh, well, I'm getting a different error now, sorry, because I'm not returning anything yet. So let's just return VIP for now. But now I'm getting an error because I misspelled that. And if I have that override directive turned off, it thinks that's just fine. Again, it doesn't understand that it's a misspelling. So I'm overriding toString, and if I come and run my code again, now instead of printing that class name and the hash code, it prints out whatever the toString method provides. In general, what we use this for is, I mean, the way I explain it is we want a text representation of the object. And so I might say VIP checking account, and then a new line, and I'm going to say balance equals. And remember, this dot balance is private, so I can't use that, but I can use the getter. And I'm going to return that once I fix my typo. And this is typically the kind of thing you use a toString method for. I often will just have it sort of dump out all of the fields in my class, just so that I can run my code, I can print it out, I can print out an object, and I can just see what all the instance variables are. So this is another example of overriding, right? In this case, we're overriding the toString method, even though we didn't write it, and up until a few minutes ago, we maybe didn't even know that it existed. I think this is a good place to stop. As is always the case, just reach out if you have any questions.